Once again, good afternoon, dear colleagues and guests. Let me declare open the session of the Dissertation Council for the Defense of Thesis of Ghoneim Mohamed Mahmoud Fathy for the degree of Candidate of Geological and Mineralogical Sciences, Specialty 250009, Geochemistry and Geochemical Methods of Mineral Prospecting on the subject Geochemical and Mineralogical Features of Intrusive Rocks, Sela region, Eastern Desert, Egypt. According to the order 3860/1 of the 15th of April 2019 of St. Petersburg University, myself, Charikova Marina Valentina, Doctor of Geological and Mineralogical Sciences, Professor of Geochemistry Department of St. Petersburg University, was appointed Chairman of this Council. Let me introduce my fellow Council members. Astrid Holzheid, University of Kiel, Germany. Alexey Viktorman, Doctor of Geological and Mineralogical Science, St. Petersburg Mining University. Skublov Sergei Gennadievich, Doctor of Geological and Mineralogical Sciences, Senior Researcher of Institute of Precambrian Geology and Geochronology of Russian Academy of Sciences. Anton Borisovich Kuznetsov, Doctor of Geological and Mineralogical Science, corresponding member of the Russian Academy of Sciences, is absent for a valid reason. And Zaitsev Anatoly Nikolaevich, Doctor of Geological and Mineralogical Sciences, Department of Geochemistry of St. Petersburg University, is absent at the moment, but we have a quorum. So let we start our session. First, let me emphasize that according to the Federal Law number 127 of the 23rd of August 1996 on science and the state scientific and technical policies, St. Petersburg University has the right to award academic degrees independently. The corresponding order on the procedure for awarding academic degrees at St. Petersburg University, on the basis of which we are holding this session of the board, was issued on the 1st of September 2016, number 6821/1. In accordance with this order, the session of the Dissertation Council is duly constituted if at least 2/3 of the appointed members of the Council are participating, but not less than 4 persons. Our Dissertation Council consists of 6 members. 4 Council members are present, thus we have a quorum. Let me set forth the procedure of today's session with a total duration of no more than 2 hours. The Chairman's brief report on the main content of the documents submitted by the applicant and their compliance with the applicable requirements, and answers to possible questions, 5 minutes. A brief presentation by the degree applicant outlining the key points of his study, 15 minutes. Questions to the applicant strictly on his report, no more than 5 minutes per question, and answers of the applicant. We don't have any external reviews. Then we shall proceed to speeches of all members of the Dissertation Council, where they will express their positions, questions and suggestions to the applicant, not more than 10 minutes for each speaker. Speech of the chairman with her feedback, answers of the degree applicant to questions and remarks of members of the Dissertation Council, no more than 15 minutes. Then we shall proceed to the open discussion, speeches of the attendees with a summary of their positions and or specific questions and suggestions to the dissertation, strictly no more than 5 minutes per person. To do that, all the speakers are kindly requested to put their names on the registration sheet. Final answers of the applicant to the questions, no more than 5 minutes. A speech of the academic supervisor, no more than 3 minutes. A 5-minute discussion before the open voting on awarding or not awarding the degree to the applicant. For the time of this discussion, the broadcasting shall be suspended. Open individual voting and counting the votes. The results shall be recorded in the minutes of the meeting. A decision on awarding or non-awarding the academic degree to the applicant, and a brief closing remarks of the applicant. Before starting the official procedure, let me remind you to switch off your mobile phones. Thank you for your understanding. Let me also inform you that our meeting shall be recorded on broadcast online at the SPBU website, and speeches shall be simultaneously translated from Russian into English and from English into Russian. So I shall now begin the meeting with our first item, the Chairman's Summary Report. Hold on, this is, it's my turn to speak. The thesis of Ghoneim Mohamed Mahmoud Fathy for the degree of candidate of Geological and Mineralogical Sciences, specialty 250009, Geochemistry and Geochemical Methods of Mineral Prospecting, on the theme Geochemical and Mineralogical Features of Intrusive Rocks, Sela region, Eastern Desert, Egypt, was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 4th of April 2019. The Dissertation Council was appointed by the order of the Academic Secretary of SPBU on the 15th of April. They have already introduced its members to you. The candidate has submitted the following documents to the University Academic Secretary: application addressed to the Rector of St. Petersburg University, Professor Kropotchev, to accept the thesis for consideration and defense, submitted on the 18th of April 2019. Feedback from the academic supervisor, Yelena Gennadievna Panova, Doctor of Geological and Mineralogical Sciences Professor. A list of 5 publications which set out the main scientific results of the thesis, including 3 articles published in peer-reviewed journals, included in the list approved by the Ministry of Education and Science of the Russian Federation. A certificate of training dated 1st of June 2018, number 048211, issued at St. Petersburg University, stating that Ghoneim Mohamed studied earth science at the postgraduate course of St. Petersburg University from the 1st of August to the day of issue, and passed his candidate exams as follows: foreign language, English, good; history and philosophy of the science, excellent; special discipline, geochemistry, geochemical methods of mineral prospecting, excellent. The next document was the Master's Diploma in Natural Sciences from the University of Minufia, Arab Republic of Egypt, on the 30th of November 2014, with translation of the diploma dated 2nd of February 2016. And then the thesis itself in Russian and English in hard copy on the rights. You may see the work here, and in electronic form. This is designed in accordance with the requirements of GOST R70. The thesis is printed on a multiplier with output data indicated according to GOST 704. It should also be noted that all the above-listed documents comply with Article 12, Section 3, Thesis Presentation Defense of the procedure for awarding academic degrees at St. Petersburg University. Thank you for your attention. Now, let me give the floor to the applicant. Let me remind you that you have exactly 15 minutes. Дамы и господа.
The topic of my dissertation is geochemical and mineralogical features of intrusive rocks in Sela region, Eastern Desert, Egypt. The territory of Egypt belongs to the uranium geochemical province. The most promising uranium deposits are granite-related vein type and associated with intrusive rocks. Uranium is a strategic element. It has a widespread use in energy sector in all countries. According to the International Atomic Energy Agency and the United Nations, the raw material of potential of Egyptian uranium is sufficiently not estimated. Egypt is a part of Arabian-Nubian Shield, and the area of study is located at extremely southern part of Egypt. The aim of the work is to identify the mineralogical and geochemical features of the intrusive formations of the Sela region to determine the prospect of their uranium-thorium-bearing mineralization. The objectives of study includes determination of radioactive elements and their associations in the rock of intrusive complexes, identification of radioactive and non-radioactive minerals of the studied rocks, assessment of the prospect of intrusive rocks as a comprehensive source of raw materials. For first time, definition of petrogenic oxides and trace and radioactive elements in the intrusive rocks, determination of minerals form of primary and secondary minerals of uranium and accessory minerals. For first time, an estimation of isolated submicrofraction of intrusive formations, the content of radioactive and association of element in it. The practical significance of the work is represented by calculation of geochemical potentials of radioactive and associated element in the intrusive rocks. Materials and methods include field work by collecting more than 100 samples, and petrographical work, macroscopic investigation. The laboratory work is represented by analysis of major oxide by using XRF, analysis of minor element and trace element by using ICP-MS. Chemical composition of minerals were performed by using scanning electron microscope and energy dispersive spectrometer. The submicrofraction was separated by water extraction using filter. The dimension of nanoparticles was carried out by nanosizor, statistical work by Excel and statistical. Spectrometric map showing anomaly of uranium and thorium in the study area. This anomaly is connected to the two mica granite, and it is dissected by different microgranite, dolerite dike, and bostonite dikes. Different field photos of intrusive rocks, two mica granite, microgranite, dolerite, and bostonite. Different petrographical views of the intrusive rocks. The average concentration of major oxides of intrusive rocks were calculated by using XRF. Two mica granite and the microgranite are located in the granitic field. Dolerite dikes are located in gabbro field. Bostonite dikes are located in the cyanide field. The two mica granite, microgranite, and dolerite are located in bare aluminous field, whereas bostonite samples brought in the bare alkaline field. The average of trace element in the intrusive rocks were calculated by using ICP-MS, and they were normalized to the Clark value according to Sklarov 2001. The highest concentration is in microgranite and dolerite. By the comparison between the average uranium content of different intrusive rocks of the study area and the other intrusive rocks from uranium provinces in Egypt and in the world, intrusive rocks of the study area have higher level of uranium comparable with others. The crystallization temperature of two mica granite reaches 750 degree, microgranite 800, dolerite 900, and bostonite 1020 degree. Two mica granite, microgranite, and bostonite are in the alkali feldspar trend, whereas dolerite are between pyroxene and biotite. The average concentration of rare earth elements of different intrusive rocks were normalized to the chondrite of Boyton and the Clark. The highest value of the sum are typical for dolerite. All samples are enriched in light rare earth elements relative to heavy ones. Based on data of the content of chemical element in the intrusive rocks, Clark uranium concentration has the highest value in microgranite and dolerite. Other chalcophile elements have high Clark concentration in all intrusive rocks. Intrusive rocks of the study area have higher level of uranium comparable with others. Based on major oxide, trace, and rare earth element classification, magma type, tectonic setting, petrogenesis, genetic features, and temperature of crystallization of intrusive rocks have been revealed. The second task of my investigation is mineralogy, investigation of primary and secondary minerals and other accessory minerals by using scan edX. And about 18 minerals were for first time investigated, they are referred in blue color. The primary thorium minerals are represented by thorite, uranotherite, brookite, and orlite. They are restricted to mica granite, whereas uraninite is recorded in dolerite. The secondary uranium minerals are represented by casolite, autunite, and uranophane. The most important accessory mineral is zircon. It occurs in all types of intrusive rocks. It can used as indicator and a good source of information about the condition of formation of the rock. Zircon of 2 mica granite is zoned, whereas zircon of post-granitic dikes are irregular without zonation. According to Biobin chart, the 2 mica granite zircon belongs to P2 and S10, and the temperature of crystallization is 700 degrees. This result is an agreement with the geochemical data. Other accessory minerals are represented by monazite, pastenazite, sulfides, and other native minerals. The intrusive rocks of the studied area contain primary and secondary uranium thorium minerals. An association of sulfides and native minerals were recorded, and about 18 minerals were diagnosed for the first time. The third task of my investigation is to determine the non-mineral form. To determine the risk of environmental pollution, it's particularly important to determine the mobility of uranium and associated elements. Comparison of data of the content of chemical elements in the intrusive rocks and their submicrofraction allows us to estimate the proportion of migration-capable and difficulty-mobile form of chemical elements. The highest value are in 2 mica granite. The highest content of uranium in submicrofraction is in microgranite. The chalcophile element, rubidium, strontium, and barium accumulates in all types of the rocks. It's possible to compare rare earth spectra in the submicrofraction with the spectra of intrusive rocks. The spectra of rare earth in microgranite and bostonite particularly didn't change. The aerobium anomaly disappeared from dolerite and 2 mica granite. The calculation of geochemical potential of intrusive rocks show that the 2 mica granite has the highest geochemical potential of uranium rare earth element, nickel, and molybdenum. The largest particle size and the highest fraction are in 2 mica granite. During the chemical weathering of intrusive rock, zinc, copper, nickel can migrate to the surrounding area. Uranium, thorium, and lead don't accumulate in the colloidal salt fraction. 2 mica granite has the highest potential of uranium rare earth elements, nickel, and molybdenum. The conclusion, based on the geochemical data, Clark concentration of uranium has the highest value in microgranite and dolerite. There is a clear similarity in the content of uranium thorium in 2 mica granite and other areas in Egypt. For the first time, 18 new minerals were diagnosed for this region in intrusive rocks. During the chemical weathering, zinc, copper, nickel can migrate to the surrounding territories. Uranium, thorium, and lead don't accumulate in the colloidal salt fraction. The least mobile element are rare earth element and yttrium. 2 mica granite has the highest geochemical potential of uranium rare earth element, nickel, and molybdenum. I would like to express my thanks and gratitude and appreciation for the Dissertation Council for their time, for patience, for reading the dissertation, and for valuable comments and for their reports. To thank my scientific supervisor, Elena Gennadievna, for her help during all the dissertation and the laboratory work. To thank my colleagues and my teachers in Egypt, Ahmed Abdel Gawad. To thank my wife for her patience and for potential support. To thank my kids, Yusuf and Lina. Thank you for everyone here. Thank you. Thank you for attention.
Спасибо. Спасибо большое.
Thank you. Before, first of all, then let us proceed to the next item on our agenda, questions to the applicant. Does anyone here have questions? Members of the Dissertation Council? Can you hear me? I was very impressed by the mineralogy part of your thesis, but I have two questions related to this part. All minerals that you found, I have this. You consider them accessory, and two groups of minerals surprised me in particular, such as copper, silver, nickel, iron. You call them accessory. And the second group of minerals, these are uranium-containing minerals, which was the main focus of your study. Primary and secondary minerals you call accessory. So these are my two questions. My first question, what are genetic features of magmatic origin of metals such as silver, iron, and copper? Первичные минералы это минералы, которые образовались напрямую из магмы и они различными факторами, такими как аксессорные минералы, это не вторичные минералы. Мы использовали классификацию, в которой имеются самые важные минералы в породе, такие как слюда. А вторичные минералы — это минералы, которые относятся к первичным минералам, такие как церезит, барит. Аксессорные минералы содержатся в очень небольшом количестве, их содержание очень небольшое. Здесь я исследовал только уран и торий. Первичные минералы образовались напрямую из магмы, вторые в гидротермальном растворе. Аксессорные сульфиды, сульфаты и самородные элементы, я назвал их аксессорными, потому что меня прежде всего интересовали только радиоактивные элементы, и другие я надеюсь изучить в своей дальнейшей работе, но здесь меня прежде всего интересовали первичные и вторичные радиоактивные элементы. My both questions, but let me ask one more question. Please go to slide number 26. I see in this slide left bottom uranites forms edge round. Can you call this accessory mineral? Да, можно назвать.
Yes, you are right.
Yes.
But
Thank you. Thank you. And I have one more question. Monazite, line shaped. Can it also be magmatic or accessory? Maybe и магматичным, и this was my first question. So you actually asked 4 questions. It was one long question about minerals. May I ask one more question? I have one more question. I am very interested to know. I think that your thesis has great practical value. Your country will benefit from your research, get access to valuable resources, but when you calculated total amount of resources, it's 6.5 tons of uranium. It
based on the equation of this equation, Q equal S, you can see, this is the area of every rock type. H is the depth. I consider this depth is 100 meter. D is the density of the rock, and the C are the average concentration of the rock. K is the coefficient. I applied this equation for, it is just a preliminary estimation. We can, I considered the area of 2 microgranite. Just a second. Yes, the area of 2 microgranite is 7,000 square meter. So this is, I used this equation. I think it can be used theoretically, and after that we can use another theories to calculate the geochemical potential.
Still, I don't understand. Is this a real deposit, or is it only, or can this amount be commercially extracted?
The area of 2 microgranite is 7 kilometers. It is. I didn't use the whole area. It is just the area of 2 microgranite. It is 7 kilometers. It is the area of 2 microgranite. You have the scale. You can calculate the width and the length, and you can calculate the area and apply to this equation.
You. So thank you. Thank you. Are you satisfied with the answer? Yes, I am. Have any questions related to the applicant's report?
And I would like to point out that your thesis has very detailed mineralogical study. The first question is about the dating of your granites. Which method or which way were they dated?
Yes, the date of granite I used just use the literature review. I didn't make age dating study. By the literature review, it is about 560 million years ago, according to Ali and the Egyptian author. But we didn't do the geochemical dating, geochronology
by literature data, what?
Uranium, thorium, lead.
By seconds?
By what?
Using what mineral?
Uranium, thorium, lead minerals. Not carbon, argon, uranium, thorium, lead.
But not zircon.
Not the second?
Zircon was used, or
monazite.
Monazite.
Yeah.
And can you show slide with zircon crystals?
Zircon, okay. Yes.
Yes. And my second question about trace elements contents of zircons.
Okay.
If I understand right, by this BCA images, zircons are very rich in trace elements. What is your opinion? Can we use such crystals for dating by uranium lab method?
I think yes, we can use zircon for age dating for uranium thorium lead.
So it's in your future plans, right?
Yes,
right.
yes.
Thank you.
I would like to do it, but it was very expensive. But in the future, I can do it.
Okay, thank you.
Thank you.
Еще вопросы, пожалуйста. Astrid, do you have?
Well, actually, I have also two questions. One is about the zircon, and you use the zircon saturation, or the zirconium, I have to say, concentration in the granites to calculate the temperature.
Yes.
Could you just kind of explain a little bit more why you actually can use in this specific area with the 2 mica granites the zircon temperature calculations?
Why I used zircon in 2 mica granite and the Bubin chart, in this chart, slide 25. Why I didn't use, why I use this zircon, what is the indication of this zircon? Do you want to know this? Yes, this zircon is an indicator for two things, for the temperature and for also alkalinity or acidity. We have two types, P2 and S10. According to Bubin chart, these two types belongs to I-type alkaline granite. This is also agrees with we have hematite alteration. Hematite alteration also is due to alkaline hydrothermal solution. Maybe also this zircon can grow with alkali feldspar granite, and for this they are alkaline, I-type alkaline granite. This is the indication of zircon. In 2 mica granite, it is regular form with zonation, but other types are without zonation and irregular forms. This is your question or something else?
Yeah, but actually, I mean, that it has to be igneous type is more or less clear, because otherwise you couldn't at all use the zircons for the temperature.
For the temperature.
And regarding the temperature estimations, I mean, there are crystallization temperatures. How are you can be sure that those zircons are not actually just some kind of overprinted, which is also some kind of often happen. I mean, they could still be in this shape, but it could be an alteration which might actually then change your calculation.
Yes, maybe these are also preliminary studies of zircon, because this chart is very accurate and needs more detailed study. We just used electron microprobe and scanning electron microscope just to show preliminary indicators for these 2 mica granites. I can know the temperature. This is also agrees with the geochemical data. We have the same temperature. It is 700 degrees for 2 mica granite, and acidity and alkalinity. So these are the use of morphology of zircon in 2 mica granite.
Okay. May I ask another question? It's actually in the beginning, also in your thesis, you have an introduction into the geodynamic in the geological setting of the entire area. And also in your presentation, you just showed one slide, and then you were not really explaining the geodynamic setting prior and after the placement of the intrusive rocks. Maybe you could just add something.
Yes, you can see in this table, there are different classifications for the eastern desert of Egypt according to the plate tectonic theory and the geosynclinal theory. According to geosynclinal theory, according to El-Shazli, we have this classification: main geosynclinal metasediment, main geosynclinal metavolcanics, thin orogenic plutonites, old granites and diorites, emerging geosynclinal volcanics, post-geosynclinal sediment, late orogenic plutonite, post-orogenic plutonite, foreland volcanics. This is the geosynclinal classification of the Eastern Desert of Egypt. There are other classifications based on plate tectonics. For example, El-Gabi and El-Ramli. The base of the basement complex consists of gneisses and pegmatite. After that, geosynclinal metasediments, serpentinite, metagabbro-diorite complex, syntectonic granite. After that, Dukhan volcanics, Hamamat sediment, gabbro post-filsite, alkali granite, younger granite, and after that, post-granitic dikes and Cretaceous complexes. In our area, at the southern part, consists only of 2 mica granites and other post-granitic dikes and veins. This classification can conclude the Eastern Desert of Egypt according to tectonic and the lithology.
So which one do you believe more, El-Ramli or El-Gabi regarding the ophiolite?
No, they are, all of them can be used, but I think in plate tectonic theory is more recent and we can use more in our investigation, are better than geosynclinal theory.
Yes, but I think it's just some kind of, whatever, in 72, they haven't realized that it's an ophiolitic sequence because they had exactly the same rocks, and then they just some kind of combined it, and they found it already in 72, but just some kind of didn't put the pieces together, say, looks like ophiolite. So yes. It's more like that they found it already in 72, just not naming it.
Yes, Eastern Desert is has a complex combination of all basement rocks. But in our area, we have only these intrusive rocks of 2 mica granites, microgranite, dolerite, and bostonite. But the Eastern Desert contain all types as mixture of ophiolite, serpentinite, and other types of basement complex.
Okay, thank you.
Есть ли еще вопросы у членов Совета?
Do members of the board have more questions? Thank you, Mohamed. Then let us proceed to the next item of our procedure, and let's read the reviews by the members, submitted by the members. I will start with the review of absent council members who are not taking part in today's meeting. If no one has any objections, I shall only focus on the key points and comments. Let me start with the review of a member of the Dissertation Council, Anatoly Zaitsev. The work is based on material collected by the author during 3 field seasons in the region of Eastern Desert of Egypt. The topic of the work is relevant and determined by the need to clarify the possible reserve and economically important chemical element, uranium. The purpose of the work of Mohamed Ghoneim was to identify the geochemical features and forms of finding uranium satellite elements in the intrusive formations. Then the author lists tasks set by the applicant, the purpose and the aim of his study. And here, diagnostics of rocks is based on their chemical composition, and there is no data on if the situation may occur where the mineralogical name of rock will be different from its chemical name. While conducting research, Mohamed mastered modern research methods and used the Resource Center of St. Petersburg University on the basis of Resource Center, typical for uranium deposits in the world. The intrusive rock was compared to existing classification uranium. They obtained data on the content of petrogenic oxides, impurities in rocks, were used in the construction of various genetic diagrams to identify the genetic features of the intrusive rocks of the eastern desert of Egypt. Based on the data on the content of chemical elements in the intrusive rocks, a Clark analysis was carried out, which made it possible to determine the rocks in which uranium accumulation takes place. Similarly, uranium and thorium content in mica granites of the studied area and other regions of Egypt was revealed. Using scanning electron microscopy and energy dispersion analysis, the primary minerals of thorium and uranium, secondary minerals uranium, were studied. Sulfides and native minerals were studied. Applied geochemistry issues are outlined in the last chapter. Movable bonds of chemical elements in the intrusive rock of the region have been identified. Now the main comments related to the mineralogical description. First, in Table 3.1, we would like to see ideal formulas of minerals. Second question, on which data the diagnosis of uranium and thorium minerals is based? These are only data on the chemical composition, or additionally used other methods, such as Raman spectroscopy, etc. Third comment, the sums in part of the analysis is 100 weight%. Are these normalized results? And if so, why? Fourth comment, the mystery is the description of the mineral hour light. Officially, according to International Mineralogical Association, this mineral does not exist. This is same is true is uranium thorite, which is not on the list of minerals. Why are these names used, and what are the reasons for this? The 4 articles on the subject thesis were published in journals from the list of the Russian Federation High Dissertation Commission. The main materials, results, and positions of the work are discussed at all national, international conferences and symposiums, which were published in the thesis of the conferences. The relevance of the work is determined by the first detailed mineralogical and geochemical analysis of the complex intrusive formations of the Sela region. Practical significance of the work is determined by calculations of the geochemical potential of uranium and REE, nickel, molybdenum, and in the intrusive Sela region. Thus, the thesis of Ghoneim, Mahmoud, Fathy on geochemical mineralogical features of intrusive rocks of Sela region, eastern desert meets the basic requirements established by the order 1st of September 2016 on the order of awarding degrees at St. Petersburg University. And applicant Ghoneim Mohamed Fathy deserves to be awarded a degree of candidate Geological and Mineralogical Sciences, specialty 250009, Geochemistry, Geochemical Methods of Mineral Prospecting. Clause 11 was not been violated by the applicant. Member of the Dissertation Council, Professor Zaitsev. The next review of a member of the Dissertation Council who is absent today is by Anton Kuznetsov. The thesis by Mohamed is devoted to the problems of uranium geochemistry and forms of its location, acidic and intrusive rocks of the Arabian Nubian Shield. Intrusive complexes in this part of the shield were formed during the Pan-African orogeny, which sank Precambrian craters into the superior content of Gondwana. The relevance of the work is determined by the need to assess the prospects of the uranium-bearing granitoids discovered in the eastern desert near the Red Sea coast in El Sela region. The study focuses on 2 microgranites, dolerites, bastanites, in which radiochemical anomalies were detected. The thesis is based on the material collected personally by the author during his work in Egypt. In his work, the author used a wide range of modern mineralogical and geochemical methods. Participated in the work of the Resource Center of St. Petersburg University, geomodel and methods of chemical analysis, as well as the Sela lab. In the first chapter, the author provides data on geology of the region and history of the study of uranium deposition. In the second chapter, he discusses the geochemical features of the intrusive intrusive rocks El Sela region, including data from various chemical analysis. Based on several traditional petrochemical diagrams, the dissertation identifies the genetic features of granitides and melt formation temperatures. Chapter 3 examines in detail the primary and secondary minerals of uranium, as well as accessory minerals found in electron microscopic studies. In the 4th chapter, the author examines the applied aspects of the geochemistry of intrusive works in the El Sela region, and for the first time for this object assesses the mobile forms of the chemical. Same chapter also calculates the geochemical potential of uranium, rare earth, and some heavy metals. In conclusion, the main scientific findings of the work are given a practical orientation on the choice of source. The results of the work have been reflected in 3 protected provisions, and the novelty of the work is determined by the detailed mineralogical and geochemical analysis of the complex intrusive formations in El Sela region and identification of forms of found in uranium and satellite elements. The practical significance of the results obtained is determined by the assessment of the geochemical potential of uranium and rare earth elements. The main remark is the unsuccessful formulation of protected provisions, which in fact represents detailed conclusions. Instead of stating the result, blurring graphical themes and blurred images in photographs make it difficult to fully perceive the material. There is no section on the methodology, which is necessary first of all for the dissertation candidate. These remarks do not affect the general qualification part of the thesis under review and the scientific results achieved. Ghoneim, Mohamed, Mahmoud, Fathy's thesis on geochemical mineralogical features of intrusive works of El Sela region complies with the basic requirements established by order, the 1st of September 2016, procedure awarding degrees at St. Petersburg University, and applicant Ghoneim Mohamed Mahmoud Fathy deserves to be awarded the degree of Candidate of Geological Mineralogical Sciences, Specialty 250009, Geochemistry and Geochemical Methods of Mineral Prospecting. Clause 11 of the order has not been violated. Member of the Dissertation Council, Doctor of Geology and Mineralogy, member of Russian Academy of Sciences, Acting Director Kuznetsov. These were reviews by the council members who are not present at today's meeting, and let us proceed to the reviews of members who are present at the meeting. Let's give the floor.
I will more summarize my report. So, I have to say thank you again to St. Petersburg State University that I got selected as an external international referee, which is an honor. Well, Mr. Mohamed Ghoneim, he studied geological and mineralogical features of intrusive rocks of the El Sela region in the eastern desert of Egypt. He conducted extensive fieldwork and selected, at the end, 24 represented samples for further detailed studies. In your presentation, you mentioned more, but in the thesis, it says actually 24. So they have now more information regarding the mineralogy, petrology, and geochemistry. And the candidate also diagnosed not yet determined minerals, so not new minerals. So they were not really new minerals, they are just some kind of not yet determined in the regions, which I was thinking first also that they would be really new minerals. But you also successfully applied well-known geochemical description methods to classify the studied rocks. And it was not only possible to link the studied rocks, including literature references, to the genetic evolution of the intrusive rocks, but also to provide main geochemical characteristics and crystallization temperatures of the studied intrusive rocks. But here I also have to say that sometimes it was not really easy to see what are your data and what are the literature data in the diagrams. The candidate derived estimates of the geochemical potential of the intrusive rocks based on the geochemical features of the minerals and, in general, of the intrusive rocks of the El Sela region. And the candidate was able to identify one of the studied rocks, namely the 2 mica granite, which has high potential to serve as source of raw materials to extract uranium, rare earth elements, nickel and molybdenum. To be more precise, the candidate provides not only comprehensive compilations of all gained geochemical data, he also links the geochemical characteristics to the intrusive rocks, to not only the uranium and thorium mineralization, but also to the rare earth element concentrations. In addition, the candidate extensively discusses the petrogenesis of the rocks, including derivation of magmatic temperatures and temperature crystallizations. As a consequential thought, the candidate in the future should gain more knowledge, more information, in-depth information regarding the uranium mineralization and the likelihood of the geochemical twins that might be linked or even trigger the mineralization, which is not yet done. And also, the candidate mentioned some correlations between major element oxides and trace element abundances, but in the future, definitely this should be more put into a genetic relationship, which is still lacking. As stated by the candidate, the greatest geological potential of being an economical important deposit has 2 microgranite of the Sela region, but as an outlook for the future work regarding prospecting in Egypt, it should be more detailed calculation of potential mining provided. It was exactly my same thought you had. And this should be not only linked to the region which you studied in the Sela region, it should be actually to more or less all other prospective sites with these type of connections regarding the rocks, the genesis, because also the entire eastern desert, you have some kind of bits and pieces with a lot of granite intrusions, and you should look in more detail if there are also mineralizations. Regarding publications, 5 individual publications do exist based on the set of references, and one of those papers has also his Russian academic supervisor, Professor Dr. Elena Panova, also as a co-author. I was just mentioning some weak points at the end, but to summarize, I'm still convinced, including the oral defense we just have, that the dissertation researched geochemical and mineralogical features of intrusive rocks, Sela region, eastern desert of Egypt, by Mr. Mohamed, Mahmoud, Fathy, Ghoneim, presented for the degree of candidate of Geological and Mineralogical Sciences of St. Petersburg State University, meets the qualification requirements for candidate dissertations on the specialty 240009, geochemistry, geochemical methods of mineral prospecting. Thank you very much.
Виктор Иванович, пожалуйста. Микрофон.
Сокращать?
Да, конечно. Я отзывы отсутствующих более подробно.
Да, я преамбулу сокращу.
Review shorter. Let me start by saying that I was very impressed by the quality. Granites in Egypt are amazing. And we didn't know about uranium content in Egyptian granites. The applicant took part in field studies. He conducted his own laboratory work, was able to interpret, and when a person does everything by himself, of course, this calls for comments. My most important drawback, in my opinion, is absence of genetic mineralogy. When you say accessory minerals, maybe these are secondary minerals, because uranium containing minerals are divided. You divide into primary and secondary, and their content depends. So this affects the actual uranium content. So the first two comments are of mineralogical nature and of some practical small amount of deposits. Uranium is estimated only 6.5 tons, and Mohamed already said that he is going to look at a wider area of only, he only looked at a territory of 7,000 meters, and maybe if you go deeper, and in addition to uranium, rare earth, we may find rare earth metals. So the applicant answered this comment already. Despite these comments, I think the author demonstrates capacity to set tasks and solve the tasks and make conclusions. So I have a favorable opinion of the thesis. The thesis of Ghoneim, Mohamed, Mahmoud, Fathy on the theme meets the basic requirements of the order of awarding degrees at St. Petersburg University, and the applicant deserves being awarded the degree of candidate of Geological and Mineralogical Sciences. Item 11 of the above mentioned order has not been violated by the applicant. Thank you. And let's give the floor to Dr. Skublov. With permission of the members of the Council, I will drop the standard, and my colleagues already mentioned some of the traditional points. Comment on the strong, on the advantages of the thesis, and so this was a comprehensive study. The author deals, because the specialty is geochemistry, is distribution and behavior of rare elements. Strong section, or the section on mineralogy is very strong, and well, the real jewel of the work, which was not mentioned by my colleagues, he studied a sub-micron fraction of the substance and behavior of rare earth elements. It includes, this is very important because granites still subject to hypogenic processes, and how this microfraction behaves will determine secondary minerals. So this is a good addition to the mineralogical. So the advantages of the work is the author uses various methods. I have not, the author did not set himself the task of isotopic methods, but which are closer to my field of study, but I hope the author will expand his field of research. The key results have already been described. Well, the testing, 4 articles published in magazines, listed by where the research findings should be, and many numerous presentations. The practical value of the thesis is also obvious. This is not an abstract piece of research, but this is a good first step to a detailed practical study, and I believe the author deserves being awarded the degree of candidate of geology and mineralogy, and item 11 of the order of awarding the academic degrees at St. Petersburg University has not been violated by the applicant. Thank you. And Dr. Skublov, and the last review shall be presented by the chairman. All the key moments have already been mentioned. What I would like to mention is the work of Mohamed Ghoneim's has been written. I remember when he first appeared at the university. This was in September 2016, though we were acquainted earlier. And he came with his own materials. He, in the next two field seasons, he got more data. I think this is very so this enabled the applicant to perform such high quality work. The author was involved in every stage of his research. I will not expand on the tasks set by the applicant. According to the tasks set by the applicant, the work is well structured, which I enjoyed. Has a chapter on geochemical characteristics and genetic peculiarities of the rocks. The next chapter is dedicated to the geochemical peculiarities of the rocks, and the chapter deals with mobile types and their geochemical potential. The main results have also been summarized, so I will not repeat what has already been mentioned by my colleagues. The results agree with the tasks set by the applicant, so we may say the applicant achieved his goals. Let me proceed to my comments. Here I've got the following comments. First, in chapter Geochemical Peculiarities of the Minerals, in this chapter, the data are presented in many tables. This part contains like 20 tables, and only for a small amount of minerals the author actually has calculations. So this form is makes understand the results more difficult. Table 3.1, as was already mentioned, will be along with the names of mineral species, will be useful to give formulas of mineral species, especially since sometimes there are discrepancies in the names of some minerals. For example, aurelite, or I would also add autenite, which has where the Russian name is also different. In my second comment, page 38 mentions the presence of primary and secondary uranium minerals in oxidation reduction conditions. It's interesting to have at least a brief quantitative description of these conditions for some of these minerals. For example, if we're talking about uranium, the potential for transition of uranium +6 to uranium +6, or the native iron nickel, and how does the author describe? And one more comment, chapter 4, devoted to the applied aspects of the geochemistry of intrusive rocks in the Sela region, provides an introduction to the various contains including analysis of in the secondary haloscatter, including the analysis of submicron fraction. This method is later used in the thesis. Data on the fraction composition of the submicron fraction for the studied intrusive rocks were obtained, but it's not clear from the text of the chapter whether it was planned to use these results in the future. Unfortunately, the text of the thesis contains quite numerous misprints and stylistic errors, which are probably related to the fact that the Russian language is not the native language of the applicant, and not all the drawings are of good quality, as was already mentioned earlier. Yet, these comments do not affect the overall positive impression of the thesis, and I have to read out the thesis of Ghoneim Mohamed. Meets the basic requirements established by the order of awarding degrees at Pittsburgh University. and applicant deserves to be awarded the degree of candidate of Geological and Mineralogical Sciences in Specialty 250009, Geochemistry, Geochemical Methods, Prospecting of Mineral Deposits, and Clause 11 of the procedure has not been violated. Thank you. So we I finished reading all the reviews, and now I would like to give the floor to Mohamed to answer all the comments at the same time. Let him answer all the comments at the same time.
Dissertation Council for your
Большое
reading my dissertation and for your time reviewing the answer of some questions. Professor Zaitsev, on which data diagnostic of uranium and thorium minerals is based? We used energy dispersive X-ray spectroscopy and scanning electron microscope. The sum of, in the chapter mineralogy, the sum is normalized. Yes, it is normalized to get large amount of work in a short time, and there is no external standard for some elements. The mystery of description of mineral orlite and uranothorite. Orlite was originally reported from Henderson in North Carolina and in Spanish granitic occurrence as a phosphotherite. Uranothorite also used in the literature review as uranium-rich thorite. The first discovery of uranothorite in Canada by a Geological Survey of Canada and also in Egypt, according to Salam et al. 2015. Some observations of Professor Viktor Alexeyev. I agree of most of these comments. The lack of data on the morphology and the relationship with the rock-forming mineral. Yes, we concentrated on the radioactive minerals, but in my future work, we will continue study in this area, and it will be a suggested project in Egyptian Nuclear Materials Authority. The absence of data of the relationship between the primary uranium minerals and secondary uranium minerals. Secondary uranium mineralization in the study area is dominated by calcium uranyl silicate minerals. The genesis of these minerals is mainly related to the alteration of primary uranium minerals in two-stages process. The first stage involves the formation of uranyl oxide hydrates as a result of corrosion of primary minerals by hydrothermal fluids. Later, in a separated stage, oxic groundwater has broken down the uranyl oxide hydrates. The liberated uranium was transported as uranyl ion and reacted with calcium and silica to produce uranophane. The interaction between the oxidizing groundwater and the corroded primary uranium minerals can be facilitated by fractures which permit the percolation of groundwater to the deeper parts of the granitic body. The low-grade wall rock alteration also indicates of ore formation by low-temperature solution. The secondary uranium minerals with distinct crystal faces were deposited near the surface from the circulating groundwater by evaporation. When conducting Clark analysis, the author performed a world Clark of intrusive rocks, disregarding the regional geochemical features of dikes of magmatism. Yes, we have no local standard like Clark in Egypt. I agree with other comments. Professor Marina Valentinovna, yes, you are right in the translation of especially word autunite and autunite. There are different translations in the literature, and the formula is important. The presence of a primary and secondary uranium mineral in redox condition. Yes, there are the occurrence of both native iron and iron oxides and pyrite. The occurrence of uranium oxides along the margins of pyrite crystals may indicate that they have played a role in the reduction of uranium hexavalent from uranyl ion dissolved in the hydrothermal fluids into uranium tetravalent, which precipitated as coffeinite. Pyrite affected by oxidation process into goethite and hematite. Goethite and hematite can absorb uranium minerals. It's not clear from the text of the chapter whether it is planned to use the result of research process. Yes, it is a beginning of the new project. I agree with the comments of Professor Kuznetsov and Professor Skoblov. Professor Astrid, I agree with her comments. About geochemical behavior of uranium and genesis of uranium deposits, they could have processed through the following successive stage. Uranium was firstly mainly trapped in the crystal lattice of accessory minerals of granites. The area was affected by the tectonic events producing faults and shear zone, which acted as good channels for hydrothermal ascending fluids and percolating meteoric water to mix with the trapped residual magmatic fluid rich uranium and thorium and generating low temperature hydrothermal system. This released uranium from essential and accessory minerals of hosting granites and redeposited as uranium minerals in the shear zone. The supergene meteoric water and superheated solution could pass through the structural network. And the question about the relationship between heterogenic oxides and trace elements. This can be explained by Harker variation diagram, the relation between silicon oxide and different trace elements. From this diagram, we can see the diffraction between different intrusive rock. They are separated magma, not direct relationship, not positive or negative relationship between the major oxides and the trace elements. And I agree with the other comments. Thank you very much for your comments and for your helping and for your reading the dissertation.
Спасибо, спасибо. Есть ли желающие выступить из тех, кто не входит в состав диссертационного совета?
Who is not a member of the Dissertation Council? No, we don't have, no. Maybe a little later we'll speak. Okay, then let us give the floor to the academic advisor. Dear members of the council, dear guests, as
проявил себя как исключительно целеустремленный, целенаправленный исследователь и работал очень активно, трудно.
He worked hard, he always achieved his goals. And we are looking at a very mature researcher. And what's interesting is once he conducted an in-depth research, he ran into a number of new questions and new tasks, which hopefully he will address in the future. Thank you. Now, time has come for the discussion of the council members. For that period, please stop broadcasting, and I'm kindly requesting everyone present who not members of the Dissertation Council, please leave the room. Thank you. Let's resume the meeting and make sure we are on air. The most important moment of our meeting has come. I put forward the open vote, the awarding the academic degree. Let me remind you that the decision of the Dissertation Council shall be considered positive if more than a half, but no less than 3 members of the Dissertation Council present at the meeting vote for it. Okay, let's start the individual voting. Let's start with Astrid. So, yeah.
Спасибо. Thank you.
Dr. Kuznetsov, yes, Sergey Gennadievich.
Я также голосую.
And I also would like to vote for. Thus, dear colleagues, the next item is counting votes. Out of 4 council members present at the meeting, 4 members voted for awarding, no one voted against, and no one abstained. The decision on awarding the degree specialty 250009 chemistry, geochemical methods and mineral prospecting is positive, and let me give the floor to the applicant for his final address.
Best day in my life. I feel gratitude and appreciation for the Dissertational Council for their help and comments, for reviewing my work, for coming and for time. Thank you again and again. Thank you for my scientific supervisor, Elena Ignatievna Ivanova, for her help in all types of dissertation and the laboratory work and her guidance. Thank you for the head of our department, Marina Valentinovna, for her help. Thank you for my wife, for supporting me, for her patience with the children. Thank you for my children. Thank you for my parents. Thank you for Boris Nikiforovich and for all guests here, and for all members of the head of the Department of Geochemistry. Thank you very much. Thank you.
Спасибо большое. Заседание объявляется закрытым. Благодарю всех за участие и просьба отключить трансляцию.
Participation.